Hi, my name is Hugh MacVS Escobia, and we'll be talking about Floyd-Warshall's algorithm with my groupmate Raymond Reyes. So first of all, what is Floyd-Warshall's algorithm? So Floyd-Warshall's algorithm is an algorithm for finding shortest paths in a directed weighted graph with positive or negative edges weight. A single execution of the algorithm will find the lengths of shortest paths between all pairs of vertices. So as you can see in this graph, Raymond would be solving this for you guys.
Good day everyone, good day to sir. So I'm gonna present the activity 10 all pairs shortest path. And first we'll determine the graphs using Floyd-Warshall's algorithm. First the A graph. In A graph in matrix 0, the self-loop or the same letters are 0. These are the AA, BB, and C and DD. They are applied to all matrix from A to B is -1, A to C is a 4, A to D is 2, B to A is a 4, B to C is 3, and B to D infinite because there's our absence of edge. C to A is -3, C to B is -2, C to A is 8, D to A is infinite. D to B is 5 and D to C is -3. And in matrix 1, the vertex A will remain unchanged. The self-loop or the same letter are 0. These are the AA, BB, CC, DD. The A to D is equal to 8, but the previous value, which is 3 less than 8, so will unchanged to B to D is equal to 6. C to B is equals to -4, which will change the previous value because it's less than -2. C to D is equal to -1, which will replace the previous number, which is 8, and from AB and AC will remain unchanged. And then the matrix 2, the vertex B will remain unchanged. The self-loop or the same letter are 0. These are the AA, BB, CC. A to C is equal to 2, which is less than 8, which will replace the previous value. A to D is equals to 5, which is greater than the previous value. The previous value, which is 2, will remain unchanged. C to A is equal to -3 and will replace the previous value, which is 0. C to D will remain unchanged because the previous number, -1, is less than 2. D to A is equal 9 and D to C will remain unchanged since -3 is less than 8. And then in matrix 3, the vertex C will remain unchanged. The self-loop or the same letter are zeros. These are the same category like AA, BB, CC, DD. A to B is equals to -2, which will replace the previous values -1. A to D is equals to 1, which will replace previous number 2. B to A is equal to 0, which will replace the previous number, which is 4. C to D is equals to 2, which will replace the previous number 6. D to A is equals to -6, which will replace the previous number 9. And D to B is equals to -7, which will replace the previous number 5. And lastly, the matrix 4. The vertex will remain unchanged. The self-loop or the same letter are 0. These are the AA, BB, CC, DD. A to B is equal to -6, which will replace the previous number -2. A to C is equal to -2, which will replace the previous number 2. B to A is equal to -4, which will replace the previous number 7. Beta c is equal to negative 1, which will replace the previous number 3. C2a is equals to negative 7, which will replace the previous number negative 3. C2b is equal to negative 8, which will replace the previous number negative 4. And that's it. And thank you.
And for this problem, I'll be solving this for you, and I'll be showing you how to solve and able to get the final output. So as you can see in this graph, there are 5 vertices. So first of all, we need to initialize the node's path to itself to 0. Set A to A is 0, and set B to B is 0, and the rest we need to distinguish every vertex and its connected edges with the weights. We need to start from A and it's connected with B, and B with a weight of 9, and also E with a weight of 2, and after that we just repeat the process until the results are in the table. So if a vertex is not connected with the other edges, then just don't put any number or leave it blank. So for iteration 1, we'll be tackling here only column A and row A. We put data on column B because 9 minus 2 is 7, and after that 3 plus 4 is 7, and after that we put the data on column E, and 2 minus 2 is equal to 0, and place the data to column A. So for iteration 2, we're just gonna repeat the process, and we'll be tackling row B and column B. So 8 plus 5 is 13, min negative 1 plus 5 is 4. If you look into iteration 1 and 2, 6 has been replaced by 0 in iteration 2. We should be looking for the current number that is lesser. For iteration 3, still repeat the process, and we'll be tackling row C and row column B, C. Add the numbers and put it into the blank spaces, and we'll be replacing them by a number if the other number is lesser. So for iteration 4, for this iteration, the blank spaces has numbers in it already. We just need to look if we can replace and exist numbers with a lesser number. For iteration 5, this is your final output. Thank you.